Good afternoon, and welcome to the Water Research Foundation webcast on full lead service line replacement guidance. My name is Jonathan Cuppett, and I am a research program manager with the Water Research Foundation, and I will be your moderator for today's webcast. Today we will be discussing the project results from a recently completed project that looked at lead reduction strategies associated with full lead service line replacement. In this project, field studies were conducted at over 100 single-family homes and utilities across North America. The results of these field studies and related case studies will be shared. In addition, experts from 2 utilities will share their experiences with replacing lead service lines in their community. The report for the webcast today is available on our website at waterrf.org. The easiest way to access that is just to go into the search bar and enter the project number. In this case, it's going to be 4713. And once you do that, that will take you to the project page. And as you can see on this slide, on the bottom right, there is a blue-green box that says Final Report. And if you click on that, that's obviously going to get to the report. If you're interested in other Research Foundation resources related to lead and copper, we do have a specific page on our website dedicated to this topic. And to access that page, just go ahead and click on Research in the top menu there, and then go to the lead and copper topic on your right. And once you're on the lead and copper resource page, my recommendation to get a better understanding of our research portfolio would be to go to the lead and copper corrosion overview paper. And this paper lists all of our LCR related research. And on this slide here, I have circled in red the best way to access that resource. And the overview paper really provides a list of the over 50 projects we have on this topic that represent over $20 million of research value. And because this topic is really a high priority for many of our members, we started a research area in 2016 specifically dedicated to lead and copper related research. And so far we've funded 4 projects. As you can see on the slide, the first one is the one we'll be talking about today. And then we have other projects that will be finalized in the near future, one on lead release from galvanized pipes, another one on corrosion control treatment, and finally one that is just getting started related to guidance for pipe loops for corrosion control treatment decisions. For those of you that are not aware, there is a collaborative group of national organizations that's developed a website that contains a lot of information primarily about lead service line replacement. The website is listed there on this slide. I would recommend going there because it's frequently updated with new information specifically about lead service line replacement. So today's presentation is not going to focus too much on the specifics of the revised lead and copper rule. However, AWWA recently held a very good webcast on this topic. And a link to that webcast can be found on the AWWA lead resource page. The easiest way to find that, or how I find it, is just to Google AWWA lead resources. And once you get to that page, if you scroll down, there is a link to a webinar that was held in January of this year, and you can access that there. And so now I would like to introduce today's speakers. Our first speaker will be Richard Brown. Richard is a vice president at the Cornwell Engineering Group. He oversees the treatment process evaluation and optimization, applied research, and regulatory compliance for public water systems, including lead and copper, disinfection byproducts, and residuals handling. Mr. Brown is a graduate of Purdue University and UNC Chapel Hill, and he has been co-PI or PI on various Research Foundation projects. Our second speaker will be Jeff Charrois. Jeff is currently the Senior Manager of Analytical Operations and Process Development Teams at Epcor Water in Edmonton, Alberta. Formerly, Jeff has worked in government, academic, and industry sectors, including Alberta Environment and Parks, as well as being an Associate Professor and Director of the Curtin Water Quality Center at Curtin University in Australia. Jeff has 20 years of internationally related experience in the areas of drinking water, wastewater, and recycled water quality, disinfection byproducts, and analytical method development. Dr. Charrois completed his PhD at the University of Alberta in Public Health Sciences. Our third presenter today will be Catherine Mello. Catherine is the Senior Director of Operations at Providence Water, where she has been working for the last 6 years. Prior to that, she worked at CDM Smith, where she was specialized in drinking water quality and treatment. Lead in drinking water has been a primary focus over the course of her professional career, and Catherine is a registered professional engineer in Rhode Island and a board-certified environmental engineer. Catherine currently chairs Rhode Island's Drinking Water Operators Certification Board. And our final speaker today will be Rebecca Slaybaugh. Rebecca serves as the Drinking Water Practice Leader for Arcadis North American. She brings 14 years of experience in corrosion control and metals release and has provided technical support to AWWA, EPA, and various state agencies on lead and copper compliance issues, including the LCR revisions. She is a member of the AWWA Lead and Copper Role Technical Advisory Work Group and a contributing member or a contributing author to the AWWA Manual 58, which is Internal Corrosion Control in Water Distribution System. Before I turn this over to presenters, I just want to remind viewers that following the presentation, there will be a Q&A period, and viewers are encouraged to enter their questions at any time directly to the webcast page during the presentation. Also, this slide deck for today's webcast is available for download, and that should be on the left of your screen under Event Resources. You should be able to download that. And an archived version of today's webcast will be available on our website on that project page within the next few days. And so with that, I'm going to turn it over to our first presenter, Richard Brown.
Thanks, Jonathan. Like I said, we did this project, WERF 4713 on full lead surface line guidance. The report is available. The co-PIs were Maureen Schmeling from DC Water, Suzanne Chivari from American Water, Rebecca Slaybaugh from Arcadis, and from Cornwell, myself, David Cornwell, and Baljit Sidhu. During this project, we had lots of contribution from participating water systems. There were 13 water systems participating in the field studies and 16 in the case studies. For the 13 field studies, 3 of them were from Canada, 10 of them were in the U.S. Of those, 1 was in EPA Region 1, 2 were in EPA Region 3, 6 were in EPA Region 5, and 1 was in EPA Region 7. The report includes a discussion and more of the details on the field studies that we did at the 100 single-family homes that Jonathan mentioned. There's also case studies, which is a whole separate part of the project. Rebecca Slaybaugh will be talking about that in a minute. And in there, we also have what we call a full lead surface line replacement guidance toolbox, which is a collection of recommendations and an associated appendix with some standard operating procedures for flushing, profile sampling, etc., some door hangers, some brochures, and other things to use to either train your staff on the lead surface line replacements or on how they can communicate with their customers, and also information for the customers themselves. In this presentation, we're going to talk a little bit about the field studies and then have experiences from the 2 public water system participants that Jonathan mentioned, a description of the case studies, and an overview of the toolbox. So the reason for this work is that there are issues with lead getting high after some kind of disturbance, including a partial or full lead surface line replacement. We have done research that shows that the whole house high velocity flushing, turning on all the faucets and running them to remove materials in the service line and in the household plumbing can help reduce lead after one of these disturbances. Now, we want to make sure to describe here the difference between high-velocity flushing and normal flushing that people use to displace water. And we're also going to talk a little bit about the procedures for the HVF. The new lead and copper rule revisions require high-velocity flushing in the house after a disturbance, such as, again, a partial lead service line replacement or a full lead service line replacement, or if you have a known lead service line, galvanized service line, or a service line where you haven't determined what it is yet, so it's still unknown. If any of those things happen, if you have a water main break or a meter replacement, you have to do the high-velocity flushing, in addition to providing filters, instructions for the filters, communication, education materials to the customers, and things like that that are outlined in the rule. The displacement flushing that most people are familiar with is the goal with that, as opposed to high-velocity flushing, is to you're only trying to remove the water in the house and replace it with water from the main. And typically there are recommendations for saying flush your water in the morning for a half a minute or for 2 minutes. And this is probably good in most circumstances. However, there are circumstances like the one shown in this drawing where we did profile samples for 20 liters, and at a normal household usage rate of about 4 liters per minute, you can see from this graph that the lead levels didn't level off till after 4 minutes. So depending on how the house, the interior plumbing, how long the service line is, you might need to have a longer flush than at other places. You just need to be aware of that. The high velocity flushing is intended to dislodge and remove the particulate material remaining after the replacement or any other remnants from the replacement process in the service line and in the household plumbing. And the idea is to get this material to be flowing to the faucet, and with the aerator removed, it will go into the drain and it'll be out of your system, so it will no longer be inside the household plumbing or in the service line. When we do the flushing, we recommend that you don't flush a faucet where you can't remove the aerators, because then you're just going to have material be concentrated there. We'd also suggest that you remind your customers not to drink or consume water from that faucet. We also suggest, if you can't bypass or remove a filter, to not flush that location, and for logistic reasons, not to do the outdoor faucets because it can create a slip-fall hazard. If you have a laundry sink or a bathtub that is capable, they're capable of producing a high velocity, we definitely recommend you focus and make sure to flush all of those, as well as any faucet you use for drinking or for consumption of food or whatever, for food preparation. So that's typically a kitchen sink. Bathroom sinks are a little bit of a problem because they're so shallow and sometimes the drains are a little restricted. So if you're running it at full rate, sometimes they don't drain out enough and they can't overflow during the flushing. And even when everything's going right, you've taken off the aerator and you're creating a lot of spray that can happen when you do a bathroom sink. So we suggest that you do bathroom sinks if you can, but if you don't have someone there to monitor it, you may be able to just leave that one off and just do the bathtub in the same bathroom. The objective is to get rid of this material, in this case, that has been collecting here in the aerator, as well as you can see this picture here, and it's a material that's been removed during a high velocity flush at a house after a lead service line replacement. Is there a delay on the slides on this showing that the slides aren't advancing? Does that look okay, Michelle?
Yeah, you're good, Richard. You're on
Okay.
past stage studies.
It was delayed a little bit. So this is the summary of the other research studies that we've done on high velocity flushing. We did one study for AWWA where we compared service line flushing after the replacement, so that's where you just flush the service line before it's connected. And we did that 2 ways, 10-minute flush and a 20-minute flush without doing the inside the house flush. And the third thing was a 10-minute service line flush followed by the whole house high velocity flush. And the results were that the service line flush results were pretty much similar, and you got much better results within the first day, and all results by the 30th day were below detection limit when you did the high velocity flush. In the WERF 4584, we found, as we did in this study, that there were metals that were recovered during the flush when we did sampling during the HVF, and we also saw that the samples that were collected after replacement and before the flush were a lot higher than before the replacement, but that they did reduce eventually after the flush when you sampled 1, 30, and 60 days after the replacement and after the HVF. In this study, 4713, the tests involved first identifying the participants. So you had to find a house that had a lead service line, and then a customer that was willing to do all of the work in this project. Now, we got all the data from all this sampling, but all this effort, which was a great amount of effort, was the participating water systems. So they had to find a number of candidate sites and keep looking for candidates that had the lead service lines and had customers that were willing to participate at single-family homes. And then once that was arranged and you got the number of houses you were going to do, then we collected one set of profile samples prior to the replacement. Then we conducted the replacement, typically with a service line flush. That was that all systems but one did a service line flush with the replacement. And then we collected another set of profile samples, which we call pre-HVF, which reflects the water after replacement, but before you've done the HVF. Then we did the HVF, and we did 3 profile samples after the HVF, 1, 30, and 60 days. When we did the HVF, we again collected some profile samples that we'll discuss here in a minute during the HVF to see how the metals are progressing during the flushing event. So again, we're talking about a flushing of cold water with the aerators removed and the filters bypassed or removed. You run it as high a rate as you can at all the faucets. And this is a confusing point for some people, so I just wanted to make sure to point this out, that what we're talking about for each house is a single lead service line replacement and a single high HVF method. So this, we did do multiple profile samples, but we didn't do an HVF at each one of those. These results reflect the only one HVF event. In this study, one house might have done one method and another house might have done another method. So we were trying to compare 2 different approaches to doing the HVF. One of them is the same one we used in all those previous studies we mentioned, and it is the same one that's in the AWWA standard. We call that all taps at once, and sometimes I call it method A. That's the standard one we normally do. But in this study, some of the houses did that, but some of the other ones did the 1 tap at a time, or method B, after the lead service line replacement. That one is fairly similar, except that you do 1 faucet at a time. So you turn on the faucet, let it flush for 10 minutes, turn it off, and then go to the next one. So we wanted to compare how effective those 2 approaches would be. So when you do the flushing in a house, you would start at the lowest level in the house and start turning that one on. If you're doing all taps at once, you turn that one on, go to the next floor and turn on the faucets there, and then go to any other floors that you have. You would want to make sure to get any laundry sinks, any bathtubs, and any sinks or other faucets that you use for drinking or consuming the water. If you're doing the all taps at once, method A, you would start at the bottom, turn them on, then when you got the last one on, you would wait 30 minutes and then go down to the bottom floor and turn them off in the same order you turned them on. And the method B, or one tap at a time, would be a lot easier. You just go to one tap at a time and flush it, but you still start at the bottom and move up. So this graph is the results of the grab samples that were collected during one HVF event. And it shows the total metals level on the vertical axis, the time on the horizontal axis. The red line is the results for iron at 2, 4, 6, 8, 10, 20, and 30 minutes during the flush. The black line is for lead, and the other lines are for other metals, as you can see on the graph. This was flushed at a rate that worked out to be about 4.6 feet per second in the service line. You can see that the black line did slowly drop during the flush. So there were metals, there were all these other metals, including lead, including iron. And for the lead and iron and the other metals, you can see that between the 10 and 20 minute point, they kind of leveled off. So the 30-minute seems to be plenty of time in this case and in other cases that we've looked at. You could possibly argue maybe you could do a 15-minute or a 20-minute flush, but I kind of like the 30-minute flush myself, as I said, because you go past the point where it leveled off and you make sure that you flushed it enough. So when you're doing the profile sampling, it's best if you can do this with more than one person because it does go pretty fast. This shows a place where everything is all cleared off, but other times the counter space can be limited, which can make collecting the profile samples a challenge. In all of these studies, when we did a profile sample, it was after 6-hour stagnation, and it was with the aerator removed prior to the 6-hour stagnation. We collected, again, profile samples pre-LSR, which is before replacement, pre-HVF, which is after replacement, before you did the flush, and then 3 samples after the HVF, 1, 30, and 60 days. There were a few water systems that voluntarily collected some other samples at other times, 2 weeks, 3 months, 4 months, etc. This graph shows one profile event, and it shows on the vertical axis the total lead, and on the horizontal axis the profile volume. So this is a pre-LSR profile sample, and you can see that the peak occurred at the 5th liter, and if you take all these 12 measurements, add them together, divided by 12, the average is 3.1. We use that. So we're going to present some data here from the peak and from the average of each profile. This is a typical profile we see with a lead service line present in that it gradually comes up and gradually goes down. We also see this when we have dissolved lead, which is what was present in these profiles. The results are shown for total lead, but almost all of this lead is dissolved. Then when we go to the other profiles at the same location, as you can see, the gray bars are the same one as from the previous graph, and the other bars show other profile events at different days for each of these profile volumes. So we have all of these for these 100 samples, and I could show you 100 of these graphs, but what I'm going to do is show you the data consolidated for all these participating water systems. This graph compares the pre-LSR results on the horizontal axis and the pre-HVF results on the vertical axis. Both scales, as you can see, are log scale, and there's a red diagonal line which indicates when the results for both of those were exactly the same. Then they would plot on that red line if the pre-LSR and pre-HF were the same number. As you'll also note, this is before the HVF has occurred, but we have indicated for you the locations that would later be flushed with HVS method A, all taps at once, versus the black X's, which are HVF one tap at a time, or method B. On this graph, if the values are below the red line, it means the LSLR value was higher than the pre-HVF. And if it's above the line, it means the pre-HVF value was higher. And these are all average data for each of those locations. So two things to note from this graph are that there are some locations where the results were lower after the replacement, even though you haven't done the flush yet. The other thing to notice, and the more noticeable thing, is that if you look above the line, there are quite a few points. It turns out to be about 60% of the data was greater after HVF. So there were, or after replacement, so there's lots of material there that was not there when in the pre-LSR sample. So this is material that needs to be removed during the HVF. The next graph shows the pre-HVF on the horizontal, the 1 day on the vertical, and you can see that after the HVF, the results were much lower, even 1 day after the HVF. So the 1 day results are the combined effect of the LSLR and the HVF, and there was quite a bit of improvement already by the first day. By day 30, there was even more improvement relative to day 1, as shown in this graph, with, again, the values below the line say that the 1 day is higher, and above the line, the 30-day result is higher. And then the next one shows 60 days versus 30 days, and you can see they're pretty similar and close to that red line. This graph compares the 60-day results on the vertical versus the pre-LSR on the horizontal. So this is before you did anything, and this is 2 months after the combined effect of the lead surface line replacement and the HVF. And you can see that in almost all cases, the results are lower below the line in the 60-day samples than before the replacement. As we mentioned earlier, the results also go higher as a result of after the replacement before the HVF. So if you look at the next graph, you will see that the data has shifted to the right, and that even more of the data is less than the pre-HVF for the 60-day samples. We talked about the average data in these graphs so far, and for the if you look at the peak data, a similar graph. It shows the pre-LSR on the horizontal, pre-HVF on the vertical. You see this a similar thing, that there was some improvement after the replacement, before the HVF, but again, about 60% of the results, the peak results, were higher after the replacement than before the replacement. Going to the next one, we compare the 60-day results versus the pre-LSR results. Again, shows before you did anything versus 60 days after. And you see that by this point, there's improvement. It's below the red line, meaning the 60-day result is lower and sometimes much lower than before the replacement. The next slide, again, shows pre-HVF peak. This is the peak. It doesn't have to be the same one. It could be the fourth leader in the pre-LSR or the pre-HF, and it might be the first leader in the 60-day sample. But whatever the peak value was, it decreased considerably from pre-HVF to 60 days or for the pre-LSR. One thing I would also like to note, going back to the pre-LSR versus 60-day graph, this graph, if you look at the data, it shows you that the results, the black X's and the blue X's are pretty similar distributed and pretty similar. So your eye tells you that method A and method B produced fairly similar results. And we'll show you some analysis here later that says that your eye is telling you the truth there. If you'll also look at this graph, you'll see that your eye is lying to you about one thing, because it looks like there's only 2 data points on the pre-LSR that are less than 1, because a bunch of the data points are plotted on top of each other. But if you look at the pre-LSR axis, there's actually 13 data points that are less than 1 microgram per liter. So the peak value was not greater than 1 in 13 of those samples. And if you did the 2 microgram per liter mark, 20 of them. So 20 of the 100 samples had a peak that was less than 2. And this was a lead service line, because we took it out of the ground and looked at it, so we know it did have a lead service line before, but in the samples before replacement, 20% of them, there was no peak over 2. So comparing the results to see if you did have improvement, did it go lower? We found that in 80% of the samples, the results were lower after the pre-LSR. And if you looked at just the results that were greater than 10 prior to the replacement, it was 94% of the results were lower by the time you got to the 2-month mark. And for HVF, it was even greater, including all of them that were greater than 10 HVF were improved by the time you got to the 60-day sample. One thing to notice on this graph, again, is that going back to the pre-HVF graph, is that this shows the net result of both the replacement and the HVF for the 60-day results. But note, if you look at the 60-day axis, the vertical, and look at the 10 microgram per liter line, you see that there are some points that are higher than 10 microgram per liter. So you've done all this effort, you've got the funding to do replacements, you've gone out and done the sampling, you've replaced the pipe, you've done the HVF. There still may be some locations with more than 10 microgram per liter peak lead. So just be prepared for that and make sure you can work that out with your customers, because they have gone through all this effort and they're going to say, I did all this and my lead is still over 10, so just be prepared to deal with that situation. The data that we looked at for each group, we found that it was not normally distributed, but we wanted to do a comparison of the pre-LSR versus 60 to see if it was statistically significant. The difference was statistically significant. When we did the pre-LSR versus 60, we found that the p-value was less than 0.001, so the difference was statistically significant using an alpha value of 0.05. And same thing for the pre-HVF versus 60. In the pre-LSR, it was 94 paired values, 70 of them from using method A and 24 using method B. They were all statistically significant, the difference. If we looked at the unpaired data for the 70 locations that had 60-day results and the 24 that had method B for 60 days, we saw that difference was not statistically different. So our data shows and our eyes show for looking at the graphs that there was really no difference between the two methods. Now, I believe and I would recommend using the method A, all taps at once, but based on our data from our research and our study, we don't have anything that says that we can prove that there is a difference. So our data says you can use either method to do flushing after the replacement. A couple of other notes we did an evaluation of where the peak lead occurred after in the pre-LSR samples, and this graph shows the number of occurrences and the percentages for the peaks that were in the first liter versus all the other liters. And you can see that the first liter had the most peaks, but when you went to just looked at the peaks that were greater than 10, the first, the fourth, fifth, and sixth were the highest. So what this says is that for the pre-LSR, a lot of it is dependent where the peak occurs on how much plumbing is in the house, how long the service line, where the lead service line is, etc. It does vary a little bit. Whereas when you go to the post-replacement samples, including the 60-day results, you see that it's always in the first or second liter. So the peaks have shifted, and now it's all inside the house, obviously, because you've removed the lead service line. This graph shows the results of the composite samples conducted by one of the participating water systems. It is ranked in order of the decreasing results for the pre-LSR sample. And you can see that that when the result was less than 4 microgram per liter before the replacement, which goes all the way up to 19J, you can see that the lead in the composite sample decreased after 60 days in all cases. If you look at 19Z, that's in the middle, so the ones to the left are the first 14, and there's 14 after that. 19Z is in the middle. If you look at all of these results, you see that even when the lead was low, the lead was lower. Lead was low in the pre-LSR. It was lower in the 60-day samples. So it's not just when it's high. Even when the lead levels are low, the pre-LSR, the lead service line replacement, and the HVF can improve the lead levels. And as we've been told, any lead level is important. So it isn't just the ones that are 10 or 100 that are important. If you can reduce the lead from 5 to 2, it's a worthwhile effort. We did do some samples, and there was a lot of effort involved by the participating water system that did sampling from a galvanized pipe with lead goosenecks. They did this at 10 points in their system, and this one graph, for example, shows 5 different sample events and 12 liters. So that's 60 samples just for that one house. They did this effort, but unfortunately, they didn't find much lead anywhere. I don't know that that's necessarily representative of other water systems, and it's probably more a reflection of the phosphate and pH and other things going on in this system. But we didn't really find much lead in any of these samples. As you can see, we did 512 total samples at these 10 houses. Only 9 of them are above the 1 microgram per liter detection limit. 6 of them were less than 2. But we did find, most of the time when we did find them, they were in that pre-HVF sample, so they were after the replacement, before the flush. And one final note was we did do some copper sampling at some locations. The water systems volunteered to do this monitoring. In all but 2 locations in the study, we did copper as the replacement for the lead. So as we talked about before, if you do your lead service line replacement, you might think that all your problems are over. And as we mentioned, the lead can still be high even after replacement and after HVF. The other thing that can happen is if you replace with copper and you have a water quality that's conducive to copper corrosion, you can have some high copper levels as a result of putting this new copper pipe in there. We had other systems that had a theoretical copper solubility indicated by this red line based on the Lytle equation that were closer to 400 or 600. This one happens to be over 1 milligram per liter. Most of the results were like house A and E, and about half of them, and about half of them were like C and D, but we did have a few, maybe one from each system, where the lead on the first day after, the copper the first day after replacement was higher even than the solubility limit. But most of the time, it did increase after the replacement from what it was before, but not above to the level indicated by solubility. But anyway, the point I wanted to make here is that you've replaced your lead, and you do have copper, but you still might want to look at ways to deal with your copper that might be present. For example, you're providing lead filters as required by EPA, but you might also want to look at and see if you can find a filter certified for lead that's also certified for copper. In summary, we did find that HVF does remove materials that are present after a full lead service line replacement, and in the other project from a partial replacement. We did see higher levels after the replacement in about 60% of the samples before the HVF, but the HVF seems to have taken care of that, and overall, the one-day results were lower than pre-HVF and pre-LSR, and 30 days was a little bit lower, and 60 days was about the same as the 30. We did find that the combined effect of HVF and lead service line replacement can improve peak total lead or average lead in the system, but you still need to be aware that there could still be some, after all that effort, some results over 10 in your houses after the replacement. We did find that there wasn't any statistical difference between methods A and B, and so and that we also did note that for when you have a lead service line present, it doesn't necessarily mean you're going to have high results if high means greater than 10 or something, but you could have some results that are, you could have 20% of our results were less than 2, so there can be some fairly low levels even with a lead service line present, and the new copper service line may create some potential for copper levels higher in the future. I'd like to acknowledge help of David Cornwell, who was involved in all the preliminary parts of this project and helped to evaluate the data as we went on. Nancy Matai was our QA/QC coordinator, and she helped greatly with the report. And Baljeet, of course, did almost all the work that we did when we got data from the water systems, and we appreciate all of their help. So we're going to be talking about the case studies, which is a whole other part of this project a little later from Rebecca Slaybaugh. But first we're going to hear from two of the participating water systems, Kathy Mello here in a bit from Providence Water, and next will be Jeff Charwa from EPCOR in Edmonton. So Jeff, if you're ready.
Okay, thanks, Richard. Good afternoon, everybody. And first like to thank Water Research Foundation and Cornwell Engineering for getting us involved in this project, and for today thanking you guys for the opportunity to share our utility experience as being part of this really interesting Water Research Foundation project. So what I'm going to be working on or trying to do today is to give you a little bit of background on our lead program, and as I kind of weave through that story a little bit, I want to try to highlight how our involvement in Project 4713 really has helped to reshape how EPCOR manages lead and how we interact with our customers based on all the experiences we derived from this research project. So maybe first I'll just quickly give everyone a little bit of background about the situation in Edmonton. In Edmonton, we have probably between 4,500 and 5,000 lead service lines across the city, which represents about 1.6% of all of our service lines in the city of Edmonton. Lead service lines, like most places, were installed from the 1910s to the 1950s, and in our case, really relates to single-family residence. Lead wasn't used in larger facilities like schools and other businesses. So our focus is residential. And probably like many utilities out there, you can see kind of our shared responsibility pictogram kind of delineating the difference between the utility side and the private side of the lead service line. And for this project, the WRF project, essentially EPCOR looked to recruit a handful of homes where we did full lead service line replacements, and then followed through with the sampling and HVF to see what the results look like. And maybe one of the first comments I'd make just about involvement with the project was it was a little bit of a surprise to us in terms of getting some of our customers signed up. I think that there were some fears that this was a scam. We were offering a free lead service line as part of a research project. So it took us a little while to recruit some homeowners, but eventually we got there and we were off to the races with our high velocity flushing program. In terms of kind of the history of EPCOR's lead program, and before we got into the WRF project, EPCOR's had a lead program since about 2008, and really the focus of that program was to work with homes that had lead service lines. And typically, the work that involved work from our program, we send out annual notifications every year to all the homeowners that we have records for lead service lines on the utility side. Records on the private side are much more difficult, so our records are really focused on the utility side. Our program for a long time has offered free lead testing in homes. We offer point-of-use filters that are rated for lead removal, NSF 53 for the removal of lead. And we often are, we historically have been working on replacing the utility side, particularly if a homeowner has replaced their side, we would go out and replace the utility side. We've been working on those utility portion of the lead service line for decades, and on average, probably 100, 120 service lines a year get removed due to a variety of reasons: repairs, water main renewals, and abandonments. But historically, there was little to no emphasis on post-replacement flushing, and so again, this is really what got us interested in this project was how could we maybe improve our program. And maybe just to highlight, at least historically in Edmonton, any lead service lines on the private side were always done at the owner's expense, and that kind of could be up to 40 per year. Sometimes it just depended on the year. In Edmonton, over the last decade, there's been a lot of infill development, and so a lot of new construction in old neighborhoods would see lead service lines being replaced. So that's where a lot of the activity has been historically. Kind of fast forward a little bit from our history to 2019, and in 2019, for those colleagues in the U.S., Health Canada sets Canadian drinking water quality guidelines, and so in 2019 in March, Health Canada came out with a new maximum acceptable concentration for lead in drinking water. This was a big review of lead research, incorporating new information on health effects, and Health Canada reduced the MAC, or the maximum acceptable concentration, from 10 micrograms per liter to 5, with an ALERA goal, meaning as low as reasonably achievable. And the massive shift was compliance would be suggested that it should be at the tap. And so in Canada, drinking water is regulated at a provincial level. So federally they set guidelines, but provincially they create standards and what becomes legally enforceable to the utilities. So kind of in parallel, our regulator, Alberta Environment and Parks, set up a document around their expectations for managing lead, and essentially our regulator was signaling that utilities would need to come up with a plan for dealing with lead within the next 5 years. And so we're working on that plan currently. But knowing that Health Canada was coming out with this document, EPCOR wanted to be proactive, and we began to develop what we were calling our enhanced lead mitigation strategy. This strategy was presented to the City of Edmonton back in March of 2019, and it was approved in July of 2019. And I think the interesting thing to share about this program was that we were essentially asking our rate regulator, the City of Edmonton, for a non-routine adjustment to basically expand our ability to mitigate lead. So the three big components of our lead strategy were to basically reduce public health risks due to exposure to lead from all sources, so not only minimizing and eliminating risks due to lead service lines, but also risks due to plumbing components, which we'll talk about in just a second, and basically looking to protect all of the drinking water users who receive EPCOR water in Edmonton and the 70 surrounding communities that we serve. So in total, we probably serve about 1.4 million customers, although some of those are through commissions that we don't necessarily deal with directly. Our strategy, of course, we wanted to proactively meet the intent of the federal guideline of 5 micrograms per liter and be ready for regulation in 5 years. The key elements of our strategy, one is that EPCOR will be adding a corrosion inhibitor, orthophosphate, and won't spend much time on that or any time on that today, but we are working on plans to bring orthophosphate into Edmonton in the next few years. But what I wanted to highlight as it relates to the HVF program was that we had a commitment that we were going to eliminate any more partials, that the utility was going to have a focus on full lead service line replacement. The request for our non-routine adjustment for the city essentially is going to allow the utility to fund both the public and the private portions of the lead service line. So anytime EPCOR touches a private lead service line, or anytime we make any changes to ours or touch ours and it impacts a private lead service line, we're going to replace it. And we also, based on our historical monitoring, have a list of our high priority customers that have elevated lead at the tap, and we were prioritizing those customers to get their lead service lines out as quickly as possible. So number 2 and number 3 essentially had a need to incorporate the high velocity procedure. So what we did, based on a lot of the work that and learnings that we took from Richard and his team as part of 4713, we developed the EPCOR high velocity flushing brochure. We also incorporated elements from the AWWA standard as well. And basically this has become routine now in terms of how we're dealing with customers. We created what we are calling the EPCOR care package, and it's essentially kind of a kit that we use when we deal with customers. It includes the high velocity EPCORized flushing instructions for what to do after the full lead service line replacement. We also provide customers with kind of a pitcher, water pitcher with filter cartridge for lead removal, some information, educational material on the lead brochure, some information from Health Canada, and like I said, the HVF flushing document. So I think, just to highlight some of the key learnings from our HVF experience, it takes a lot of time to do customer engagement right. So we know that there are a ton of coordination elements that are required, both in the preparation for the customer as well as the construction on site when we are doing full lead service line replacements. We had some challenges, particularly in Edmonton, with issues of resident versus owner. But we've worked through that, and we are working with the owners of the lead service lines for kind of approval to remove them. And like I mentioned earlier, there is customer fear of scams and things, and so at times we have to explain that no, this is real, and these are sort of the objectives of trying to get the lead service lines out. In terms of other key things, I think we were really interested to find out that the lead can increase initially after a replacement, and how important high velocity flushing is to get effective removal of particulate out of premise plumbing and to reduce lead at the tap. We know that it may be 2, 3, 4, 6 months, depending on working with the customer, to ensure that lead is below our maximum acceptable concentration at the tap, and additional HVF may be required, and we're committed to working with our customers. So this kind of picture here is just the EPCORized HVF instructions inside our pamphlet, working from the bottom of the house up and back down, as Richard was pointing out. And essentially, I think, in terms of final thoughts, our enhanced mitigation strategy is, in our view, a comprehensive way to be proactive, to meet the Health Canada guideline at the tap, and to ensure that drinking water quality is met, and we fully have incorporated health, social, environmental, and financial considerations. So with that, that's a little adventure on the EPCOR story, and I'm going to pass it over to Kathy here. I'll just advance the slide, and thank you very much. Kathy, over to you.
Thank you very much. Good afternoon. My name is Kathy Mello. I'm the Senior Director of Operations at Providence Water. Within the next 10 minutes or so, I'll give you a brief introduction to Providence Water and our lead service line replacement program, as well as discuss our experiences with this study. We have at Providence Water, we have a single source of supply. It's very consistent and has high water quality. Water flows by gravity from the Scituate Reservoir to our water treatment plant. We have the largest conventional water treatment plant in New England, with a max day capacity of 140 million gallons, and our current average day demand is about 60 million gallons. We provide water to 2/3 of the state of Rhode Island through our 5 retail and 7 wholesale customers. We're located in one of the oldest parts of the country, and sections of our distribution system do reflect that to a certain degree. We have some cast iron mains that are over 100 years old. While they are structurally sound, many have become tuberculated over time. We also have approximately 27,000 lead service lines within our distribution system. Providence Water owns from the public side, from the main to the curb, and the homeowner owns the private side from the curb to the meter. Of all of the lead service lines, we have about 16,500 that are private side only, with the remaining being full lead service lines. Providence has a multi-pronged approach to reducing lead at our customers' taps. In 2018, we rolled out a 3-year 0% interest loan for private lead service line replacements. In 2 years, we had about 460 signed agreements. We polled people who decided not to participate, and the main reason they cited for not participating was cost. So as a result, in June of 2020, we rolled out a new loan with a term of 10 years, and over the past 6 months, we've received about over 600 agreements. I should note that when a private side is replaced and we find that the public side is also lead, Providence Water will go out and replace the public side as soon as possible at no cost to the homeowner. In terms of water main rehabilitation, within the past 5 years, Providence Water has spent about $15 to $20 million per year. We target older areas with unlined cast iron main, and those areas usually also have lead service lines. We replace the public side, and we notify those in the area of our loan program. For corrosion control, Providence Water has used pH and alkalinity passivation for about 100 or so years now. But in January of this year, we implemented system-wide orthophosphate. At the time of the WRF study, we had one small isolated pressure zone within our distribution system within which orthophosphate was being added. We had 5 locations within the study that were located within this orthophosphate demonstration area. We do have a robust public education program, which we'll talk about a little more in the next slide, and we have a formal unidirectional flushing program through which we flush about 90 miles per year. Okay. Providence Water follows best management practices for lead service line replacements. Within our water main rehab program, we deliver 45-day, 14-day, and 24-hour written notification to all affected homes. The 45-day notification includes health and procedural information about lead service line replacements, as well as a copy of our 0% interest loan agreement. Upon completion of a replacement, the contractor does flush outside at the outside spigot, and then beginning in the 2018 construction season, we began following the 2017 AWWA standards for lead service line replacements and flushing. We now send detailed instructions for whole house flushes, or high velocity flushes, if you will. The method that we recommend is similar to that of method A, in which we open multiple faucets for at the same time. We recommend a flush duration of 10 minutes. When we do have partial lead service line replacements, we always use plastic couplings to connect the dissimilar pipes, metals, and we distribute a 6-month supply of filters that meet the NSF 53 criteria to every unit affected. We also deliver sample bottles at every location for post-flush samples, and on average, we get about 50% of those returned. Results of all lead results, are mailed to all of our customers, and in instances where elevated lead levels are found, we do call those affected customers within 2 business days to talk to them about troubleshooting, mitigating, and of course, our loan program. So at Providence Water, we jumped at the chance to participate in this study. We collected some very useful data, but we also had some challenges. So one thing that we thought was going to be a big challenge but turned out not to be was customer participation. At the time of the study, we actually had a backlog of customers waiting for our for replacements due to contractor workloads and backlogs. So we offered to push volunteers to the top of the list. We didn't need any further incentives, and since then, the backlog issue has been resolved. As I said, we were eager to participate. So when we were preparing our proposal, we thought, 30 locations this is very reasonable. Then the time came for execution, and we got the very detailed protocols, and we just realized, our in-house staff, we just don't have the in-house staff available for this amount and degree of field work. So we hired a consultant to coordinate and conduct all the field work and prepare results. We actually hired CDM Smith out of Providence, Rhode Island. The contractor who replaced the private side lead service line also replaced the public side at the same time, so it was a simultaneous full replacement. Our preference would have been to use our in-house staff to replace the public side, but again, with the rigorous protocols and schedules of this study, which we do appreciate, it just didn't make we weren't able to coordinate that. So the private contractor conducted the full lead service line replacement. High velocity flush samples. So the WRF protocol called for a lead service line replacement with a contractor flush, and then the next day you go in and you take your pre-flush samples, immediately followed by a high velocity flush, and then the following day after that you take your one day post-flush profile sample. So this was contrary to the message we've been trying to tell our customers, in that we really want them to flush before they use the water, and this is the messaging that we had been sending. So what we did is we worked with everyone in the study, and they were great, and we modified our protocol so that we were on site for the lead service line replacement, and immediately after it was done, like within minutes, we went into the house, we collected our pre-flush sample, conducted the high velocity flush, and then the next day we went in and collected the one day post. So that ended up working out quite well. We did acquire a lot of really great data, but in the beginning we did struggle with how to communicate this data with our customers in a way that would be meaningful to them. So this is what we came up with. Basically, so it's obviously a bar graph. The green bar is water collected from the faucet, yellow from the household plumbing, and gray from the lead service line. And we took the highest concentration of lead within each category for each sampling event, and that's what is put onto this graph. So the idea is that when this customer at location 7 sees this graph, and it was sent out with a formal letter, they'll say, okay, before I had my lead service line replaced, I did have some appreciable lead, and within the service line itself, after the replacement, lead levels went down, and by 30 to 60 days, it looks like it resolved. So this is a graph that was prepared by our consultant, and this was for more of our internal use. This graph is for the same location in the previous graph. This is a post-replacement sample results. So the orange line is pre-flush, and the gray, yellow, and blue lines are post-flush. There are a couple takeaways here. We saw a similar trend across the board in that the first liter typically had the higher lead levels, and we did see elevated the pre-flush, post-construction, pre-flush samples typically had higher lead levels than we would see in the profile samples. So if you remember from the previous slide, the high lead level at this location was about 65 parts per billion, and the pre-flush lead level was upwards of 1,800 parts per billion. So this graph really highlights the effectiveness and actually the necessity for flushing internal plumbing post-replacement. We also looked at, it's not reflected in this graph, but we looked at the lead concentrations from the samples collected during the high velocity flushes, and that confirmed to us that 10 minutes is a reasonable duration for our whole house flush or our high velocity flushes. Some other quick lessons. We had this really cool opportunity where we had one portion of our distribution system that contained orthophosphate, and one was treated with pH and alkalinity. So we had 5 sites within the orthophosphate demo area, and then we had 25 within the area that received pH and alkalinity adjustment. We realized that this is a very small sample set and a snapshot in time, but what we did see was that all orthophosphate sites had lead concentrations below 9 parts per billion 1 day after the flush. So 1 day after it was replaced and flushed, they were below 9. In the non-ortho area, only 20% of the locations had similar results to that. We also took advantage of this study to look at some other metals. We looked at iron and manganese at 12 locations. So in addition to total and dissolved lead, we looked at total and dissolved iron and manganese. We wanted to see if the high velocity flush was also effective at lowering iron and manganese concentrations. The good news was that our iron and manganese levels were low across the board, but because of that, we really couldn't quantify the efficacy of the high velocity flush for that purpose. We also collected pre- and post-composite samples at 29, I believe, of the 30 locations, and as expected, the post-replacement samples were lower across the board. Identification of lead sources, we're in an older part of the country, and we have an appreciable amount of lead service lines, and we're also finding that it's not unusual at all to find sections of lead pipe within the homes themselves. So through this study, through the household piping audit, of the 30 locations, we found 4 locations had lead pipe within the homes, and 1 had a galvanized pipe within the home. And galvanized for our system is a little unusual, but the lead was not. Of the 4 locations where we saw lead within the home, 3 of them were replaced with the lead service line replacement. So I'd just like to take a minute and thank the Water Research Foundation and Cornwell Engineering Group, Arcadis, for giving us the opportunity to participate in this study. In particular, I'd like to thank Richard Brown for his patience and guidance, and Baljeet for her patience and guidance as we, got a handle on this study. And also, I'd like to thank the folks at CDM Smith and Providence, namely Lauren Kershaw and Megan Bogle, who really had quite a task of knocking on people's doors at times of days where, they really didn't want to be answering the door. So we appreciate all the work that they did and all the data preparation. So that's it on my end, and I will now pass it along to Rebecca.
Great. Thanks, Kathy. Good afternoon, everyone. So I know we're running a little short here on time here, so I'm going to jump right into the case studies. So as shown here, we were focusing on identifying trends and summarizing protocols, successes, and challenges amongst utilities that had already developed and conducted full lead service line replacements. We had 16 utilities that were participating in the case studies, most of these being surface water systems that had corrosion control treatment in place. We collected a wide range of information though from these systems. For the sake of time today, I'm going to focus on just some of the high-level trends around their programs, but do want to note that there's a lot of additional detail provided in the full report on each of these systems. So first up, I'll talk about the inventories. All 16 systems had already developed a lead service line inventory and were asked about the sources that they used to do this. As you can see here, most of them had used water system records to initially develop this inventory. Most had also said they were primarily updating information based on visual verification during the actual service line replacements, and largely doing this via paper records. So a lot of times there was a lag in between when the information was collected and put back into their system. Also of note, most of the systems did find lead on the customer side where lead was present on the public side, but that was not uniform across all the participants. In terms of the replacement goals, many had established goals for replacement either over a long-term period, up to 30 years, as you can see here, but 3 had actually established specific annual replacement goal rates, and those ranged anywhere from about 100 to 5,000 lead service lines per year. Additionally, when we started this project, many really noted that they began their programs focusing on opportunities for replacements only as part of planned capital improvements, but evolved their program over the years to identify other ways to engage and proactively reach out to customers and get them to replace known or suspected lead service lines. We also then did inquire about partials, and as you can see on the figure on the right here, there were several systems that noted that they still were performing partials on a regular basis or only when the customer refused to replace their portion of the service line. Another area that we inquired about was around cost. Many noted right off the bat that it was really difficult to predict and track replacement costs. As you can see here, there was a wide range of costs reported for both partials and fulls, so anywhere from $2,500 to $7,100 for partials, and for a full replacement around $3,500 all the way up to $15,000, and that varied both across the systems and even within the systems. I do, however, want to note that, again, many were not recording a lot of the cost information in detail as they were starting out their programs. So these costs don't always include the same components. They generally include the materials and labor, but may also include costs for restoration, sampling, administrative, and other costs largely around record keeping or digital or data management. In terms of the funding sources, most reported that they were using capital or operating funds. However, a few systems did actually increase their water rates or obtain funding from the state specifically to cover these costs. Additionally, for all the systems included in the case studies, the customer owned some portion of the line. So we asked about opportunities that the systems had in place to help cover the cost for replacing the customer-owned portion. We found that nearly all the systems were providing some level of assistance, typically through loans or incentives. Loans were provided and generally ranged anywhere from 1 all the way up to 15 years at interest rates between 0 and 5%. And in some cases, systems only provided these loans to low-income customers and did that through an application process. For incentives, the range was anywhere between $1,000 and $2,500, and usually the customer was reimbursed after the replacement was completed and paid for initially by the customer. Also of note, 6 systems were covering the entire cost of the replacement, even though they did not own the entire portion of the line. We also asked at the start of this study about post-lead service line replacement flushing procedures conducted in-house, and had found that all but one were conducting or recommending some form of flushing as part of this study. That one actually did end up implementing additional procedures as part of this study, however. For the other 15 systems, you can see here that actually all of them were using the all taps at one method, generally recommending 30 minutes of flushing, and 2 of those systems actually had procedures as well for the 1 tap at a time to allow flexibility for their customers to perform some of the sampling. In terms of who did it, there was a split. I'd say 2/3 of the utilities reported that the customers were doing it, and 1/3 reported that they had their staff or contractor staff conducting the flushing. Also want to note that about 40% of the participants actually don't meter during the flushing, so that was something we were inquiring about as well. We also asked about sampling practices around lead surface line replacement and had found that all but 2 conducted some form of sampling. More than half were sampling prior to the replacement. When we asked about after replacement, we got a wide range of responses, as you can see here. So most were sampling following the flush, but a small number were doing it further out and actually at multiple periods after the replacement, all the way up to 6 months after. In terms of the protocol itself, most were collecting using 1-liter sample bottles, using a first draw method. However, some were doing full profiles either routinely or only after an initial single sample result was high. We also asked about filters. So most of the systems were already providing or planning to provide filters following replacements. For those that did, all of them were providing pitcher filters, but some did give an option to their customers for faucet filters, either in place of or in addition to the pitcher filters. One also noted that they were considering under sink units, but determined that these were too difficult to install and maintain, so actually ended up scratching that idea. We also asked a lot of questions around how these filters were selected, the replacement frequencies, and cost. All had noted that the minimum criteria for selecting a filter was NSF 53 certification, but there were other factors that were considered, including results sometimes from in-house testing that was performed by the utility, recommendations from other utilities, costs, which you can actually see on the right-hand side, and availability. Also, all provided some amount of replacement cartridges, though the number generally varied really based on the manufacturer's recommendations around replacement, but lasted to cover anywhere from 1 to 6 months. The replacement frequency was generally based on manufacturer's recommendations or a total dissolved solids meter where one was included in the filters. Also, it was interesting, we got some select feedback from the utilities that they heard directly from the customers around these filters. Some noted that they received broken pitcher filters. Some stated that they never received a filter. Wanted to note, though, that none of the utilities were mailing these. They were either dropping them off directly at the customer's location or had provided centralized locations that these could be picked up. Around the TDS units, some actually noted that their customers thought that that measurement actually represented the lead content. So there was a lot of confusion and communication around that, and some also noted that the TDS meter did not always work. Some did also note that the filter itself was easy to use, but hard to install when they were using the faucet type filter. With respect to communication, just quickly a high level, want to note that most of the utilities were using multiple methods for notifying their customers around the opportunities for replacement, notification of work, or information on the type of material present, as well as educating their customers. You can see a couple examples on the right-hand side. Not going to spend too much time on this because Richard's going to go through this in a little bit more detail. But in general, not one method was found to be more effective than another. Most were using a combination of methods to reach their customers. Given the volume of customers that the systems were trying to reach, we also asked around training. Most did have some form of internal training that they were doing for their staff, typically in a PowerPoint type form, on how to communicate with their customer around the lead service line replacement program, and then would give information that would direct customers to a specific water quality staff or the head of the lead program if there were questions that they could not answer. We also asked about reasons that customers may not have participated in the program. The most common answer was customers were unwilling or unable, but several did note that there were challenges due to high volume of renters or vacant homes in their system, as well as low participation in non-English speaking areas of the utility system. Some actually noted that they found that they had to do some additional translations into other languages to try to increase participation for those customers as well. And then we also just asked more generally if the customers were following the recommendations around sampling, filter use, and flushing. Most were not formally tracking this, but anecdotally, we did hear from the utilities that most of their customers were very proactive and engaged, and in general had more questions around the flushing protocol itself. And some noted that the customers were not actually doing the flush, largely because of concerns over wasting water. We did ask for some information around customers or around utility rates for their water and wastewater, and roughly estimated that the flush would cost no more than $2, depending upon the duration and or frequency, as well as the wastewater costs to complete this. So to wrap up, some conclusions from the case studies. Most of the participating systems developed their initial inventory using historical water records and were updating it based on actual information in the field as part of the replacements. Most used capital funds for the replacement and offered customer financing options. And just wanted to note that one system that was actually covering the entire cost of the replacement noted that they had about 99% participation in their program. In terms of post-lead surface line replacement flushing recommendations, most were using the whole house all taps at once method with the aerator removed. And then in terms of sampling, we saw just a wide variety of results, both around the timing and the specific procedure. So a few lessons learned: record keeping key, a lot of data to manage, and that was a big struggle for many of the utilities. They managed and adopted different data management procedures along the way. In terms of participation, that was a challenge for some of the utilities, and many noted incentives were key to increasing the number of participants. Multiple methods of communication with the customer are definitely more effective than a single method, as I noted. And then last, definitely something we heard from everybody is that these programs need to be flexible, and many were either actively or on an annual basis renewing or reviewing their overall program to make sure that it met their customer needs and their system goals. So with that, I just want to acknowledge some additional staff members that contributed to the case studies: Karen Kaslos and Vicki Nystrom from Arcadis. And I'll turn it back over to Richard to wrap up some information around the guidance toolbox.
Okay, thank you, Rebecca. We do have some time limits now, so I'm going to go through this material a little bit. Most of this is in, all of this is in the report, and that is the prime mechanism for reviewing this information. We intended it as a good reference document. So we do have, wanted to just outline some of the materials in there. We talk about some of the, basically broke it down to pre-replacement and post-replacement activities. So we have some information on lead service line replacement, and on how to communicate with customers before the replacement. And then after the replacement, we have information on, from this study on the whole house flushing, as well as the service line flushing, which is where you connect to a hose bib and flush after the replacement. Some monitoring, which we recommend people do, but some people don't have the time to do those. We talk about customer communication, not only directly with the customers, but training the water system staff and their vendors to do the communication with the customers, to provide information on health effects and importance of doing the flushing and things like that. Some best practices were indicated for the customers, including replacing anything that has lead in your house, using waters that are not only ANSI NSF standard 53 but also certified for lead, and that we also might suggest that they look for filters, if it's a water system, some filters that may be certified for copper as well, just if you're concerned about the copper from the new copper that is replacing the lead. We have a few example materials. We have some SOPs that describe how to do the composite sampling or the high velocity flushing or the profile sampling. Some example, this is a one-page brochure on 2 sides, which gives an example of how to do the whole house high velocity flushing that can be filled out by the water system for their own use. There's also some infographics that were prepared and included in the appendix in our report that shows how to do the HVF one at a time on the right and all taps at once on the left. An example notice from Philadelphia Water on what to do when you do an inspection, and have something ready for when you do the inspection and don't find a lead service line. thinking a little bit outside the box there. This one is an example of what procedures to use when you're cleaning and being ready to repair your faucet aerators and screens. I will turn it back over now to Jonathan for the questions as we have time for them. Appreciate your time and appreciate all the efforts of all the people involved in this project, including the speakers today.
Okay, well, thank you, Richard and Kathy and Jeff and Rebecca. Great presentations, a lot of good information. And for those of you that are looking at the time, we finished just right on time perfectly, right? So we usually have a Q&A, and we have a fair amount of folks that are still with us. And so we're just going to break the rules a little bit and take a few minutes and ask some questions. There's a lot of great questions that have come in. So let's just sort of jump into it. And we'll start, I guess, with several for Richard. So several questions came in related to the flushing procedure and using or not using the hose bib outside of the house. So can you talk a little bit about how that, you did use that, didn't use that, how that whole hose bib flush may have factored into this project or this concept of full lead service line replacement?
Okay, the hose bib flush is what I was calling the service line flush, and that is something we highly recommend, and we think that we consider that part of the replacement process. So that should be done after the replacement, but what we indicated was that we did not recommend that you do outside faucets during the whole house high velocity flush. So during the service line flush, yes, very definitely, and we encourage that to be done. We know that some cases it just can't be done, and in that case you just do the best you can. But any time that you can do that flush through the hose bibs, we definitely recommend and encourage that. But we don't suggest that you do it during the HVF. One is just for purposes of, if we're doing this in February, we're creating, spills and ice and slip hazards, and so we wanted to make this more universal for multiple applications. If you're in other times of the year, maybe you could use the outside faucets, but we were trying to make it more amenable for that purpose as well.
All right, thanks. So another one for you, Richard, several questions. So you presented a lot of data and several questions just trying to clarify, was the data presented today for full lead service line replacements, for partials, a mix of both? Just sort of talk a little bit about, where you're referencing for fulls versus partials.
Okay. We did the ones that I briefly mentioned where we had a galvanized service line and a lead gooseneck, and those were the only ones in the entire study that were partials. So as a result of that replacement, they replaced the galvanized service line and the gooseneck on the public side but left the private side. But all the others, they replaced all the lead that was present. In most of those cases, there was lead on both the customer side and the public side, and both of those were replaced during this project. Some of the people, as Katie mentioned, they committed to a large number of locations, and they weren't able to get all of them as full service lines prior to the replacement. So there were a few that had lead either on the customer side or the public side, and in this case, for this project, they replaced all the lead that was present in the service line, so that after the replacement, there was no lead in the service line. So all of them in this study were full replacements. A few of them were replacements of a little bit of the partial of the lead remaining, but after the replacement, there was no lead remaining in the service line.
All right, thanks. So I guess this one would probably be for Jeff. And there was a question that came in regarding filter kits after a lead service line replacement, and do you deliver them, or just can you talk a little bit about how that process works at EPCOR?
Yeah, no, thanks, Jonathan. That's a great question. When it comes to our care package, and as we line up full lead service line replacements now, the kits are deployed early on, long before the service line is replaced. So we kind of highlight to our customers if they have a lead service line, they should be using a filter and kind of being mindful of that. We kind of let them know that after the replacement, as we've seen in the data here, that they could expect lead to go up. So it's important to be continuing to use that even after. And then we do our follow-up to make sure we kind of give them a clean bill of health with a lab certified value. So the kits are deployed long before construction, and they've been a really great tool to help us with those customer interactions.
Okay, thanks. So I guess, a question may have come in. This one might be for Kathy. And so the question really is trying to better understand, the question is, was the internal lead plumbing inside the home, near the foundation where the line enters the home? So just trying to get some clarification, I think, on where the lead pipe or where the lead plumbing is in relationship to foundation or inside the home.
Sure. So we had 4 locations where we found lead. 3 of them, the lead pipe was just downstream of the meter. And one of them, interestingly enough, it was just upstream of the faucet.
All right. Thanks. And then I have one perhaps for Rebecca, perhaps for the group. And so a question is trying to get some more information on historical water records, specifically for the private portion of the service. And so, again, I'm not sure. This kind of came in later, and so I don't know if Rebecca, do you have any thoughts on the historical records, specifically for the private section, and any information from that?
Sure, yep. I would say most of the participants had said that they had more robust records on the public portion that they owned. In some cases, some did have some tab cards or records that provided information on not only the material at the main, but also on both sides of the curb stop. But most, in terms of the records, it was more robust on the public portion.
All right, thank you. So, Richard, I'm going to jump back to you. I've got 2 or 3 more quick ones. Thanks, folks, for hanging in there. You had a lot of graphs with different time frames. So, pre-lead service line, pre-HVF, post-HVF. Can you just kind of run through one more time the timing of when you did the profile sampling for the field studies?
Okay. This is Richard. The key event was when the lead service line replacement took place, and that the timing went from that. So if we were scheduling a lead service line replacement this week, we might have collected the pre-LSR sample last week, or we might have collected it earlier this week. The point was it could have been collected the same day as the replacement, it could have been collected a day or 2 before, or it could have been collected a week, just sometime prior to the replacement. And then we do the 1 day and 30 day and 60 day after we're all just based on whenever the HVF event occurred. The HVF, as Kathy noted, we tried to have most utilities participate by doing exactly the same with a 6-hour stagnation on the sample. So they would do the replacement, wait a day, do the pre-HVF sample, then do the HVF, and then 1 day after that do the 1 day post-HVF. But we did have about a third of the water systems that were not willing to do the wait the 1 day, so they would collect the sample later that after the replacement and prior to the HVF, as Kathy mentioned, a few minutes, sometimes a few hours, but basically some of them did do it the same day as the lead surface line replacement and HVF, so they could do it all with the same crew, the same day, the same house.
So there was a profile done prior to the lead service line being removed. Then there was a profile done after the lead service line was removed, but before the high velocity flushing was performed. And then there were profiles taken after the high velocity flushing was performed at like 130, 60, in general, 130 and 60 days after. Is that correct?
Yes, those are the profile samples.
Yeah. All right, so we'll do one more question. Thanks so much for hanging in there. And so this question, so Richard, you talked about composite sampling. There's a couple questions that came in for clarification on that. Can you just clarify what you meant by composite sampling in this project, or how that was handled?
Sure, it's described in the report. I'll give you an outline of it. We asked, the water system asked customers to collect the sample. They gave them a 1 liter bottle with 100 liter markings made on it, and every time they used the water, they were supposed to fill to the next mark. So if it's at the 200 mark, they fill to the 300 mil mark. And then when they get it filled up without overfilling it, they would ask the water system to come by and pick up the water sample, and it would be analyzed. And we had them do it for these. That one graph shows, for one system, shows them being collected before the replacement. Again, sometime before the replacement, not necessarily the same day as the pre-LSR profile sample, and then someday around 60 days after the replacement, not necessarily the same day as the 60-day profile sample, but sometime around 2 months after the HVF.
Great. Well, thanks, Richard. Thanks, everyone, for all the presentations again, and we're going to wrap that up. Apologies for running a little bit late. And just a reminder, there's going to be some survey questions that pop up on your screen as you're exiting, so if you could answer those, that really helps us out. And also a reminder, there is going to be an electronic version, an archived version of this webcast on the project page within the next few days. So thanks again, everyone.